The problem here is that for the following function, state the parent function and the transformations that have been applied, and then graph the transformed function. So the function that we're given is f of x equals negative 3 times x plus 8 squared minus 5. So the first step would be to identify the parent function, which is f of x equals x squared. So the parent function has been reflected on the x-axis and has been vertically stretched by a factor of 3. Now, we got these values from a, and a here is negative 3. The negative sign makes it reflect on the x-axis. To be a reflection on the y-axis, it would have to be a negative sign in front of the b value. Here, there is no b value, or the b value is considered to be 1 here, because there is no vertical compression. And the vertical stretching by a factor of 3 is also determined by the a value, and that's where the 3 comes from. It's also been translated 8 units to the left and 5 units down. Now the 8 units to the left comes from the c value, and that's why it's plus 8 instead of minus 8. If it was minus 8, it would have been translated to the right, but since it's plus 8, it's translated 8 units to the left. And the 5 units down is determined from the value of d. And if d was plus 5 in this scenario, it would be translated up, but since it's minus 5, it's translated down. So now while graphing this function, you'd first graph the parent function, which is f of x equals x squared, which is just a simple parabola. And then when you graph the transformed function, which is here, you can see the following transformations being applied. The negative 5, which means you're translating 5 units downwards, is shown here. 1, 2, 3, 4, 5. And that's exactly where the point is. However, it's also translated 8 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, which gives you the vertex of the new parabola. The negative 3 shows how it's being reflected over the x-axis from the parent function, and the 3 also shows how it's being vertically stretched by a factor of 3, which makes it appear skinnier than the parent function.